Now we'll be looking at access control strategies, how access control policies can be decided. By discussing the access control policies, describing access control rights for different classes of actors, and describes how objects guard against unauthorized accesses. In multi-user system, different actors have access to different functionality and data. If you have a multi-user system, then you need to define those users will be having what sort of access of the data depending upon the functionalities they will be carrying out. Now during analysis, we model these different accesses by associating different use cases with different actors. Now here, during the analysis phase only, we try to decide over the access control policies, taking into consideration the different accesses by associating different use cases with different actors here. During system design also, we decide certain access control policies. We model these different accesses by examining the object model by determining which objects are shared among actors. Depending on the security requirements of the system, we can also define how actors are authenticated to the system and how selected data in the system should be encrypted. Here we model access on classes with an access matrix. Now this is a matrix consisting of rows and columns. Rows represents the actors of the system and column represents the classes whose access we want to control. There, if an access matrix have an entry in a particular row and column, it is considered as an access right. So it has an entry in the access matrix and it lists the operations that can be executed on instances of the class by the actor. Now we have ways to implement this access matrix. First, we can make use of global access table. Now this table represents every cell in matrix as actor, class and operation tuple. There are three sort of information here in this. Every cell in this particular table, that is global access table, will have a tuple including these three information: actor, class and operation. Determining if an actor has access to a specified object requires looking up the corresponding tuple. If you want to find out which of the actors are having which access right, then you have to look at a particular tuple combination in the table. Second option we can go for is access control list. So access matrix can be implemented using access control list. It uses two sort of information. Each class to be accessed include actor and associated operation. If an object is accessed, its access list is checked for its operation. For example, we make guest list when we want to throw a party here. The third option that we can implement access matrix as a capability. Now it associates class operation pair with an actor. See, with every actor, it will indicate what is the association to a particular class with the actor, as well as what sort of operation will be carried out here. A capability provides an actor to gain control access to an object of the class described in the capability. For example, an invitation card for a party. Now this table shows access matrix for a bank system. Now the system is named as tellers here. Now tellers can perform small transactions and inquire balances. Managers can perform large transactions and access branch statistics in the system. See, this example is of access matrix for a banking system. Now there are objects such as teller, manager and analyst. In this particular scenario, we are considering only three actors, or we can say objects. Now let us see what sort of transactions can be done by these actors. Say for example, teller. The tellers can perform small transactions, or it can check for balances, like small transactions like debit, credit, or it can examine balance. Similarly, manager as an actor have access control over the branch statistics, as well as it can do some additional operations like small transactions, credit card, debit card, or some of the large transactions on debit and credit card, even examining the balance and also looking at the history of transactions. So it has some additional accesses. Now if we look at analyst, so analyst can access statics for all of the branches but cannot perform operations on the account level. So here in this table you can see here the operations over the account cannot be done by analyst, whereas analyst is having an access of looking at the statistics over all of the branches of that particular bank, other than examining the branch statistics. I hope you have understood this example nicely. Now we'll see the designing global control flow. Control flow is actually the sequence of actions in a system. Sequencing is important here. We have to figure out which of the actions are taken in what order. This will give you sequencing. So sequencing actions include deciding which operation should be executed and in which order. Now these decisions are based on external events generated by an actor or on the passage of time. So either these decisions we can make when an external event is triggered by an actor, or with the flow of time. As the time passes, we can switch to some other events here. Now there are three possible control flow mechanisms. These are procedure driven, event driven and threads. Into procedure driven control, the control resides within the program code. For example, main program calling procedure for subsystem. This is the simplest example we have taken here. Here you have a main program which calls for some other program inside this program for executing certain code. It is simple, easy to build, but it is hard to maintain as it requires high recompilation cost. Now here is an example code for Java procedure driven control. An event driven control resides within a dispatcher calling function via callback. The control of the program is within the dispatcher, which is calling the function via callbacks. This particular method is very flexible and is good for design of graphical user interfaces, and it is also easy to extend the functionality. Now here we have a sample code of main loop for event driven control, which is implemented in Java programming language. Looking at threads, as we know, thread is a thread is a simple set of function which is active, a particular component which is active at that particular time. We call it as thread. Concurrent variation of procedure-driven control. So threads are concurrent variation of procedure-driven control. It is arbitrary number of threads created, each responding to a different event. As many events we have, as many threads we have in the system. For every event, we have a thread of execution. So there are arbitrary number of threads created. Now this method is most intuitive of the three mechanisms. Out of the three mechanisms we are discussing here, this one is the most intuitive one. Debugging threaded software requires good tools, but it do have some constraints. We require a high-end debugging tools here. Now here is an example code for an event processing with threads in Java programming language. The next point we'll be discussing is about identifying services. To identify services, we first need to identify the main subsystem. Then allocate responsibilities to each subsystem. Refine the subsystem decomposition by identifying the services provided by each subsystem. Also, you need to review dependency between subsystems and define interface for each services that you have identified. You also need to name the identified services here. Then identifying boundary conditions. We have to decide on how the system is started, initialized and shut down. In order to decide these policies, we further have to define how to deal with the major failures, such as in case you have data corruption or there is network outages, which is caused by a software error or a power outage. We also need to state here the use cases that are dealing with these conditions, and which we call it as the boundary use cases.